Hello everyone, in today's video I want to introduce you to PGP theory and give you an overview and introduction of PGP. So let's dive right in. First off, what is PGP? And PGP stands for Pretty Good Privacy, and it's an encryption program used for encrypting and decrypting everything from text to emails. You can do digital signatures with it, certificates, and so on. So now that we know what PGP is, let's dive into the background, how it started, and who created it. So it was created in 1991 by a software engineer named Phil Zimmermann. The name Pretty Good Privacy actually spawned from a grocery store name called Ralph's Pretty Good Grocery. So that's how the algorithm got its name. And the creator, Phil, was actually an anti-nuclear activist and created the software PGP so that he could send information over securely to fellow activists and friends that cared about the cause as well. So PGP quickly found its way around the world. It gained a following. People started using it to securely transmit information without anybody spying on them. And so that's how PGP grew very quickly. One interesting fact about PGP expanding into different countries was that Zimmermann was actually investigated by the government in 1993 because PGP was exported without a license. So crypto systems that met certain qualifications were not to be exported outside the US at that time. But after some investigation, it was closed and Zimmermann was not found guilty of breaking any laws. However, being an activist, Phil Zimmermann found a way around that investigation and possible restrictions by providing and writing a book which outlined how to build your own copy of PGP, and that book wasn't part of any restricted list for export, so people could just read it, scan in the pages, and build their own copy anywhere in the world. As far as where PGP stands today, in 2010 it was acquired by Symantec, and so since its acquisition it is Symantec owned. So that's the status of PGP today. And moving on to our next topic would be the structure of PGP. So we'll dive a little bit deeper into how that works. So the way PGP works is that it uses encryption on serial combinations of hashing, data compression, public and symmetric key cryptography. And each step uses a few supported algorithms. So a public key is tied to a username, and the first version of the system actually was known as a web of trust, which is a hierarchical approach based on certificate authority, and which was later added to PGP. And its very current version actually uses encryptions that include both options through automated key management servers. The PGP fingerprint is a public fingerprint, which is in essence a shorter version of a public key. As we all know, public keys are very long, and a fingerprint will get you the key in a much shorter fashion. As far as compatibility, it's an interesting topic. PGP has evolved. Different people have different versions of PGP. So the two participating parties between the information exchange need to communicate and understand each other's capability and definitely agree on PGP settings so that the information transfer is smooth with no errors and won't take too long. There is a more recent PGP version called OpenPGP, and in that version, trust signatures can be used to support certificate authorities creations. Those signatures can indicate that both of the keys belong to its claimed owner and that the owner of the key is in fact trustworthy enough to sign the keys one level below their own level. There is also a way to revoke identity certificates. And lastly, in more recent versions, we also have certificate expiration dates, which could be set as well through PGP. So now let's take a look at how PGP works. So when a user encrypts anything plain text with PGP, the software compresses that plain text, and then it saves a modern transmission time and disk space, and more importantly, it strengthens the cryptography security. Then what PGP does is it creates a one-time session key, which is a secret key, and it's a random number that's generated from something as deep as the movements of your mouse or the keystrokes that you type on your keyboard. And this section key works with a very fast algorithm to encrypt the plain text. And the result we get is called ciphertext. Once the data is encrypted, the session key is then encrypted onto the recipient's public key, and the public key encrypted session key is transmitted along with the ciphertext to the recipient. So that is how the encryption works. So now we need to know, when you're the recipient, how does the decryption works? And it just works in reverse. The recipient's copy of PGP, which, as we mentioned, has to have the same settings as the sender so that no data is lost or miscommunicated. So the recipient will use his or her private key to get a temporary session key, which PGP then uses to decrypt the ciphertext. Now that we have learned about encrypting and decrypting data using PGP, let's talk about digital signatures. That's a very interesting topic, and I want to discuss it in this presentation because it is a significant part of the theory of PGP. So digital signatures enable the recipient of information to verify the authenticity of the information's origin and also verify that that information is intact. More or less, a digital signature serves the exact same purpose as a handwritten signature. However, it's very easy to counterfeit or fake a handwritten signature, while a digital signature is superior because it's nearly impossible to counterfeit. So the way digital signatures are created is, instead of encrypting information using someone else's public key, you encrypt it with your private key. If the information can be decrypted with your public key, then it must be originating from you, and there is your digital signature. With signatures covered, I want to talk about hashing and the hash functions of PGP. So hashing will help you produce a fixed length output for any message. So that'll save you a lot of space and time. And PGP uses hashing to generate a message digest, which is a fixed length data portion. And we'll get into that. So what hashing will do is it'll take variable length input. So let's say, for example, a message of any length, even if it's thousands of millions of bits, and it'll produce a fixed length of 160 bits. And you can see how beneficial that is to the communication process. PGP uses a cryptographically strong hash function on the plain text the user is signing, and that generates a fixed length data item, which we know as the message digest that I mentioned earlier. And if the information is changed, then a totally different digest is produced to see that PGP is actually doing its job. So now that I've told you everything about PGP, you're probably wondering, how safe is PGP? And that's the next thing I want to talk about. I will tell you one thing, no one has been able to break it as of yet. So in my opinion, they need to name it very good privacy instead of pretty good privacy, because that is impressive. PGP not only protects data while it's traveling between two parties communicating, but it can also protect the data that's stored on a disk or anywhere else in the digital space. I have read numerous articles in the internet about organizations such as CIA, FBI, some of the special cyber units in Europe who have been unable to break PGP. So a lot of bad guys actually use PGP certificates and protocols to transmit their data knowing that nobody could break it. So, point being is if you need a solution, of course, for good purposes to encrypt data, to keep data protected through communicating, PGP or pretty good privacy is your answer. Thank you for watching, and I hope you've learned more about PGP theory today.